Couple of things that we can use our radians and trig for is arc length and sector area, finding about pieces of this circle that we're working with. So when we're asked to find the length of an arc, basically what we're doing is we have this piece of pie here. It's kind of cut out of our circle. We're trying to figure out how long the crust of the pie is, basically. But here's the kicker, and this is what everybody always forgets, and then they get it wrong. The formula for arc length isn't hard. It's radius times angle. But this is the key. It has to be in radians. If it's not, we need to convert it. So for instance here, I've got my radius, it's 11 feet. Okay, that's no big deal. But then that 315, I can't use it in degrees, it has to be in radians. You can either do work off to the side, or how do we normally turn degrees into radians anyway? Okay, so you could just do 315 pi over 180, because again, it'd just be pi over 180 times the 315, and do it that way. So, again, it's kind of a personal preference type thing. But we are actually going to end up going to decimals on this, and we're going to go to the nearest tenth, because we normally don't go around and speak in pi. At least most of us don't. But when I'm looking for the length of the arc, again, one-dimensional, so it's just going to be, in this case, it's going to be feet. If it's already in radians, well, that's even better. Then you just work with what you got. You don't have to make any conversions of any sort. So we can keep that simple. And again, I don't have to worry about my order of operations stuff, because since everything's multiply and divide, it's going to work left to right anyway, which is what I want it to do. But again, anytime you get that theta measure either in the picture or here and it's in degrees, you've got to make that conversion. Because if you don't, you won't end up with the right answer. Because we are continuing to talk in Trig's love language, which is radian. Now, when I move from that, because again, that formula is not going to change. There's no exceptions, anything like that. When we get to the length of each arc and it says do not round, now we're going to get very specific, and we are going to speak pi. So for instance, if I get to 9, I'm like, okay, so I've got 8. I'm just going to put it over 1 because I'm going to go into fraction world here. I have a 315 degree angle, but I'm going to multiply it by pi over 180. So I'm like, okay, let's see. So 315 times 8 would be 2,520 pi over 180, but I believe that reduces, oh yeah, 14 pi. So when we talk about do not round, if you get a fraction, so like if you got 7 over 2, 7 pi over 2, then leave it as that, okay? Don't round. So I'm not saying you'll only get whole number answers. I'm just saying no punching it into the calculator. We literally are going to make the transformation and then work it that way. But again, if it's already in radians, leave it that way. Keep it simple. Then my other side, one more formula. It's 1/2 radius squared times my angle measure. Again, has to be in radians. If it's in degrees, change it. So again, up here at the top, we'll do it with some rounding. So 1/2 times my radius squared. And then 60 degrees, that's just me. I know my 60 degrees in radians because it's like my unit circle. times pi over 3. Now again, since we're rounding this time, since we're going to be specific, I look and I go, okay, let's see. 10 squared is 100, half of that's 50. Less typing I have to do in the better. Times pi divided by 3. And again, now I'm looking for area. So now my measurements are in squared units. And I have to be sure that I do that. And then when I get to the not rounding, it's the same thing working for me again. So I've got 1/2 times my radius squared. And again, when I'm dealing with a lot of fractions and wanting to just simplify, I like making everything a fraction. You don't have to. And then again, you would have 240 degrees times pi over 180, or again, if you're good going along with your unit circle, you can just make that change over in your head. But otherwise, the big thing is just remembering the formula. And I'm going to assume this one's going to go down. And this is what I was talking about before. If we're not going to round, if we're going to leave it in radians, sometimes you're going to get answers that look kind of ridiculous. You probably wouldn't go up to somebody and say, hi, the area of this sector is 512 pi over 3 square feet. But sometimes we need to be a little more specific than others. And I can get to my answer that way. So just put them in, multiply straight across. Yes, sir. Uh-oh.
Did you use the half?
Yes, because what I did was I went ahead, I multiplied across the numerator first to get this, and then I did the 2 times 180 to get that denominator answer. So if you wanted to, you absolutely could have done like 16 squared, took half of it, and then worked it from there, and maybe even got it down to 2 fractions before you started, like 128 times, let's see, 4 pi over 3, and that would have gotten you to the same place. But yes, I did remember my 2 this time. Okay. Any other questions on how to get these guys set up? Like I said, we're on a light Friday here.